something like this. All right, it's now time to talk about DO, Directive, Orchestration, and Execution. So up at the very top of this, you can see that I've written 3-layer software architecture. That's because that's what DO is. It is a 3-layer system that we're wrapping around an AI agent in order to help constrain its outputs and take it from like a probabilistic thing, which is all over the place, to something very standard, consistent, and deterministic. So at the very top of this system is your directive layer, of course. This is going to include workflows and SOPs. And by the way, if you don't know what SOP means, that stands for Standard Operating Procedure. And standard operating procedures are very common in any sort of business, which is one of the reasons why I like DO so much. Because all you really do is just import your standard operating procedures in whatever business you are working with, whether it's your own or a business you're helping. Then you just say, hey, turn this into a directive as per DO, and boom, you're done. You now have like an AI agent that just does tasks that your company needs to do. So up at the very top, kind of the first layer is this directive. Now underneath, you have the orchestration layer. Your orchestration layer is your AI agent or AI employee in a way. And you'll also see that like not only did I put a little robot face here, but I also put a person. And the reason why is because it's actually pretty similar to how most organizations work. You have some high-level directives. Those directives are read by employees or, other people in the business. And then what they do is they just make decisions surrounding how to accomplish the high-level directives. This is where they perform coordination, task management, and stuff like that. And what they do with those decisions is they call or use tools. Now, if you're an AI agent, you're going to be using mostly software tools as expected. Hell, if you're an employee, for the most part, you're going to be using software tools now. Think of the tools that an average employee uses in any organization. We're using Google Sheets, Excel, we're using Microsoft Word, Docs, right? All of those things are actually analogous to tools that we use within an organization to accomplish things. And it's the same thing that our AI does with tools that it creates. Okay, so down at the very bottom here, you have the execution layer, and this contains tools, it contains Python scripts, and so on and so forth. It's primarily responsible for action and output. I don't want people here to be really scared or worried about DO. It's a lot simpler than you may think. The thing is, we just need to frame it as like a 3-layer software architecture in order for the rest of the course to make sense. So to be clear, DO is literally just a folder structure plus a system prompt. And pretty much all frameworks out there right now for agentic workflows are. All we do is we just set up a folder called directives and a folder called execution. Then we add some files like an AgentsMD, ClaudeMD, or GeminiMD as our prompt. And then, we might add a .env for our API keys, etc. Again, the .env is literally just a convention that, some programmers made forever ago. So it's great for beginners, primarily because it's intuitive and it's really easy to understand. And it's also really cool for businesses because we can just copy and paste SOPs directly in. Like a company that I'm currently working with right now does marketing specifically for dental practices, and they do about $2 million a year. And when I introduced agentic workflows to them, kind of like in a meeting, I met with the director and I started discussing how, hey, I think we could probably automate a couple of the previously non-automatable tasks with agentic workflows. He's like, okay, so how do we start? And I was just like, well, you guys got a knowledge base. Why don't I just feed the entire knowledge base in and see what happens? And within 15 minutes or so, we had actually procedurally turned most of those things into agentic workflows. We had all of the API keys, we had everything that we needed preset, which was lucky because a lot of the time you have to jump around and, finagle various services. But yeah, within 15 minutes, we had turned this into DO, and we now have a workspace that, the director, managers, and myself can use to do like 90% of the economically valuable work. Is that going to lead to some headcount reduction? Probably. When you automate 90% of 10,000 people's roles, obviously you need to take a step back and start doing more management style stuff than actually getting your hands dirty. But yeah, that's just a very simple and straightforward example of something that I have actually just now done. The reason why DO works really is because of the whole stochasticity idea. And stochasticity, just for anybody that's like, why the heck is Nick using all of these crazy words? It's just the way to formalize randomness, I would say. It's a little bit different, but for our purposes, you could use that. So it just takes this big, if this is like the total range of possible outcomes, okay? You could do this outcome, you could do outcome somewhere here, you could do this outcome, you could do outcome somewhere here. All DO does is it just reduces this so that the range of possible outcomes is a lot more narrow. And so, for the most part, we're operating within a very tightly bounded range of possible outcomes for our system. It can do this or it could do that, and it's very, very similar. Because we do this through the separation of concerns, it's just a lot more reliable. This lets me get to 2 to 3% error rates on a lot of business functions. That dental marketing business that I was talking about earlier is a great example of that. It's really not more complicated than that. I also like to think of it as, I don't know if you guys have ever gone bowling or something, but this is going to be my crappy bowling pin thing. You know, typically the way that bowling works is you have gutters on the side. And, you know, if your bowling ball is not very good, or if you are not very good at bowling, I should say, you know, like a lot of the time it's going to veer off into the gutter and then you're screwed, right? So as a total newbie, one thing that I really like doing is I like asking them to set up the guardrails. So I say, hey, do you mind setting up the guardrails for me? And then they set up these little guardrails that basically prevent the ball from landing. And so what ends up happening is I basically will bump off of a wall and then I still get to hit some pins. That's all Do is for agents. It just constrains it. We just give it some guardrails and then we significantly improve the probability that it does something that we want. So I'm going to go very into detail here and be very comprehensive because this is the framework we're using for the rest of the program. You've already seen me use this a bunch through the various demos that I've created. Now I just want to provide context for everything. If some of this stuff is repetitive or if you think you already know this stuff, that's okay. I would recommend just watching it regardless. Try and internalize as much of this as possible because this is the same idea that any framework is going to use. So the directives, obviously, are SOPs written in natural language as markdown files. Markdown is very important. File ending, all will end in .md. That's obviously stands for markdown. And generally speaking, this is just a sort of like markup language. A markup language just formats text. So this is plain text, for instance, right? First, SOPs are written in natural language as markdown files. Marked up version of this might be first. Let me make sure I got this right. You had some stars. SOPs, and now this is bolded text, are written in, natural language. And so now it's like quoted text as markdown files. What we're doing is we're taking text and then we're just marking it up. We're adding some structure to it, basically. Markdown is just one way to do so. So for instance, this on a page is actually markdown underneath it. I used markdown to help, I used AI actually to help me convert a big 17,000 word document into a slideshow. And so this was actually a heading. And the way you demonstrate or the way you use headings in Markdown is you use little number signs. So for instance, if I wanted to write this big heading, I actually would have written this. Layer 1, directives. Underneath that, you have bullet points. Bullet points in Markdown are little stars. So star, first, SOPs are written, right? So all of these little characters are just ways that you add formatting to text. And the reason why we do this for our AI agent for directives is because formatting allows us to add a lot more informational content to the text. It also allows us to structure things. So it's not just one giant massive text dump. We get to add new lines. We get to add various tabs for indentation. Basically, we just add a bunch of structure to things as opposed to it just being this, right? We basically convert it into something that is a lot more interesting. We have spaces and we have little bullet points and, this structure of the text kind of looks like a face, funnily enough, allows us to impart a lot more information per token. And then it's also token efficient. There are other markdown languages as well. One that you've probably heard of before is called, or markup languages as well. One that you've probably heard before is called HTML. With HTML, the way you mark things up is you use a variety of tags. And so tags are these little number sign things. If I were to try and write the same thing in tags, it would be significantly less token efficient. And so I'd actually have written way more total tokens, which obviously would have consumed a lot of my context. So instead of that, instead of the HTML, body, H1, layer 1 directives, H1, whatever, all we're doing to accomplish the same thing is I literally just do a number sign. Obviously, this is one character. That's like, I don't know, however many characters. Way more, obviously, to just demonstrate some structure there. Okay, so that's Markdown. Now, these define your goals. They define your inputs. They define your tools, your expected outputs, edge cases, and ultimately a lot of other things that you can define. I don't proclaim to have the perfect directive creation structure. I'm going to show you my own directive creation structures, and that tends to include all these things. But in general, you just want to provide high-level overviews. Now, the way I write these, or the way I have AI write these, is I write them like I'd instruct a competent employee. I would make them clear, but I would not micromanage. And really, AI does this for you. All I do is I describe the what and the high-level hows of my task in Markdown, and then I just trust the agent to figure out the rest. I'm going to remember to drink this tea because it is going to get cold. Damn, that stuff's good. Holy. So directives obviously live in the directives folder in our workspace. The way I separate each directive is as a separate Markdown file that covers one workflow or one capability. For instance, I would have a scrape _leads.md file, but I wouldn't have a run_business MD file just because, and maybe we'll get to this point later, I don't know, but just because this is a lot that we're asking from the model, and so the model typically starts looping over and doesn't really understand various edge cases and stuff like that. I constrain these into sort of like modular directives, and then later on, I can actually group them with umbrella directives. Not umbrella to the point where it's literally like, hey, run my own business, but umbrella to the point where it's like, hey, run onboarding flow or something like that. So some examples: lead underscore scraping MD, proposal underscore generation MD, email underscore enrichment MD, and so on and so forth. I highly recommend making the names descriptive. Logically speaking, these are the only things that descriptive. This is the only way that like the model can tell kind of what's going on here. You can, of course, add some other forms of structure to the text. You could add what's called YAML front matter, which I'll talk about a little bit more later on. But for the most part, like the model just consumes the name and then uses that name to determine which workflows it's going to use. If I say, hey, I want you to scrape some leads, obviously it's going to do the lead scraping one, right? But if I just call that L_S with some bullshit naming convention, it would have no idea what it's doing. So very important here to just like be descriptive. Don't use acronyms. Don't use anything that like complexifies the names of the directives if you want the agent to be able to use it as best it can. Very important point is that directives contain no code at all. There is zero code within a directive. All directives are natural language instructions. We don't have any code, no executables, and really there's very little technical here. I may include some URLs. I say, hey, go to this URL in order to get information about this, but I'll never actually include any sort of code or executable. The reason why is because we want these directives to remain readable by all humans within the organization, and they should just make sense to all people within the company. If your directives are to the point where they're so technical and confusing that like any, average low-level staff member within the business could not read it and understand what's going on, you've screwed up. The whole idea is that you want to lower the barriers to entry so that anybody in your company that is system-minded, they don't have to be technical, but they have to know systems, can actually just improve things. You'd be like, oh, yeah, take a look at that directive and let me know if there's anything that you think I'm missing. And then they just read it, natural language, and they go, oh, sometimes customers ask for X, Y, and Z. We should probably add some logic there, right? You want that person to actually be able to substantially improve the organization. You don't just want it to be like a black box, because that's one of the main benefits of this, right? We're making this really, really interpretable. We're removing bottlenecks across the organization to have people see and understand how the systems in the business work. Okay, so next up, we're going to talk about layer 2, which is orchestration. This is kind of like the who. Orchestration is basically a competent project manager. So a good project manager in business rarely actually does the hands-on work themselves. They're basically just like a nexus, and that nexus takes information in, and then it kind of puts information out. And, this might be person 1, person 2, person 3. They're going to take inputs from these 3 sources. They're going to do some thinking, and then they're ultimately going to go and delegate some additional work to person 1, 2, and 3. So they make routing decisions at the end of the day, and they take advantage of available tools. If you think about old school no-code flows like N8N and stuff like that, this job was basically done by you, and you would orchestrate it once when you built the flow. You'd say, this node goes to this node goes to that node goes to that node goes to that node. Maybe this thing loops around a little bit, and then eventually we, do this node or something like that. This is a decision that you would make once when you built the flow. What's really cool is the orchestrator basically just does all of that on its own. So if I just show you guys as like a practical example here, the orchestrator instead just compiles all the tools, and then at runtime, it decides, hey, I actually want to do this, and then this is actually going to go over here. After that's done, it's going to go over here, that's going to go over here, we're going to loop back 3 times over there, start over here, and then we'll finish over here. And because it's flexible, it can adapt to any situation at the time that you are asking it to do things. You just give it tools, and then it just does all the routing and stuff like that for you. Obviously, we want to provide at least some structure, right? We don't want to just give it a bunch of tools and say, hey, figure it out. That's what our directives are for. So it does ensure work gets completed according to those. But the flexibility here allows it to deal with situations like when something breaks, how to diagnose the problem rather than just crash and 404. And then later on, if you use subagents, like I recommend throughout the program, we're going to have like a documenter flow that not only will go through, see workflow end to end. If there's any problems, it'll diagnose it and so on and so forth. It'll actually go back and it'll document for the purposes, or rather the benefits of future instances of the agent, changes that it made, things that, the agent needs to keep in mind, logical errors that, maybe agents typically make to avoid API exceptions that don't really make sense or work, and so on and so forth. All right, layer 3 is execution, which is the how. So logically speaking, execution is deterministic. It's very modular. It's very straightforward. Doesn't mean it's simple. The execution scripts are stored in the execution folder. I typically just use Python for this. Why? Because the programming language doesn't really matter, to be honest. And when you have Python, like at any point in time, if you needed to, you could convert this into whatever the heck you want. You can convert Python into Rust, you could convert into Node, you could convert it into Java. I mean, like whatever language you want, really. These things are all essentially just conversions of natural language at this point anyway. Each script handles just one thing, so one job or one task. I'll give you an example just using what we talked about earlier. So if I have like a scrape_leads directive, this is like the high level kind of workflow, right? Now this workflow isn't just going to have one, scrape_leads.py script. This might actually have multiple different scripts. This might have, depending on whatever you're using, might be like scrape_appify.py, might have like a upload to gsheet.py. Hell, it might even have, if you have to make some interface or something, present to user.py. But the point is, these things all just do one thing really well. So this one scrapes Appify really well. This one uploads to a Google Sheet really well. This one presents to a user really well. These are just like things that, you like tools that an agent can use in order to do some task. So what happens is, because they're deterministic, they do the exact same thing every time when given the same inputs. So like if I were just to, do this, raw dog it, and just feed in some prompt to my agent and say, hey, I want you to scrape Appify for X, Y, and Z, and I had no tools and no directives, it would eventually figure out what I want it to do. But if I did it 10 times, on route 1, it would go from here to here, and then on route 2 it would feed back, and route 3, we just have fundamentally different executions every single time, right? When you have the exact same inputs provided to the exact same execution scripts, and then you get the exact same outputs, it becomes very obvious like what the model needs to do, and you heavily constrain the inputs and outputs, and you essentially just provide a simple rule. Hey, if I say, hey, scrape Appify or whatever for Texas for 200 people, it'll actually feed that in as a parameter to the scrape Appify. It'll actually like have location equals Texas, for instance, and then amount equals 200 or something like that. And because we are being extraordinarily explicit here, there's never any misunderstanding. So the agent just always knows what to expect. So do you. Another example here would be scrape_Apollo. That would scrape leads from Apollo, but maybe you also enrich the leads. Well, now you have enrich_clearbit. Maybe that enriches company data via that tool. Maybe you then have a send_email that sends emails via specified service, and then a create pandadoc, which generates proposals. What you'll quickly realize is when you build a sufficient enough library of tools, you can have multiple directives reference the same tools. Like for instance, the send_email py. Maybe as part of my scrape_leads.md directive, I always send an email with a summary of the leads, right? So maybe, somewhere here I say, hey, generate the leads, scrape it with Apollo, and then send an email. Well, what about the create pandadoc? Maybe in the create pandadoc, maybe I have like a generate proposal MD. Well, the generate proposal MD also needs to send an email. Well, what's really cool is when you define these atomic functions, both of these can call the same execution script. And because we've optimized the hell out of these execution scripts by rerunning and self-annealing and all this stuff, which I'll talk about later, this is really robust and it basically like works every time. Execution scripts are not AI for the most part. They don't hallucinate. They don't make things up. They basically either work correctly or they throw a clear error, so there's no ambiguity. There's a programming term here called unit testing, which basically means like you can like isolate this down to its bare bones function, just its input and its output, and you can just test that. You can version control them, so you can have like a log of updates. And you can optimize them independently. You could start with like some sort of serial flow where it goes 1, and then it does 2, and then it does 3. And then after a few runs, maybe it'll come up with a more efficient way to do things. For instance, maybe it'll split it and it'll parallelize 1, 2, and 3, and then recombine the inputs or something for some API call. The options here are virtually limitless. But because they don't guess or hallucinate, you can just incrementally improve these things over time. I had this question come up the other day, so I figured I'd answer it in this course. Nothing says you can't actually use AI inside of your scripts. For instance, you might have a thing called process leads with, _claude.py that, it feeds in a bunch of leads or grabs the leads from like a Google Doc or something or a Google Sheet. And then it just like passes them all through Claude and has you tell something about each lead. I don't know, whatever the heck you want this to say. Well, you can still use AI to do that for you, right? It's still passing it into Claude. It's just doing so in a much more predictable way because you are defining it within a single workflow as opposed to just like giving it full orchestrator access. Like for instance, your process leads with Claude would probably start by like reading the sheet, right? That's probably what's going to happen under the hood. After you read the sheet, it'll then send each row to Claude. When you do that, you'll have a specific prompt that is like it's not deterministic, but it's as deterministic as possible. You set the temperature really low. It like expects the same outputs for the same inputs and so on and so forth. After you're done with that, maybe you like add update to sheet or something. So you can call, OpenAI, Anthropic, Google at your whims. I do it all the time within my flows. And actually AI is a pretty big chunk of how I do things. I also call like neural networks and stuff like that. I use various libraries. You don't have to just, do it all with old school Python automation. I guess the point I'm trying to make is just make these execution scripts very atomic, make them do one thing and just make them as deterministic as possible. This will significantly improve the quality of your end result. So why does this DOE model work? It works because it plays to everybody's strengths. When you do not constrain the outputs of LLMs, they're really unpredictable, right? They'll try anything, and when they fail spectacularly. And it might be like they work 80% of the time, but the 20% of the time they don't, they will like blow up a building or something. Pre-built tools replace the construction of tools on the fly. Because the LLM is running pre-built tools, it doesn't have to make them from scratch every time, which reduces the total number of steps that you have to take to get there. A really simple analogy for this is imagine if you just gave somebody a recipe versus asking them to invent a new dish every time. Like if I just said, hey, can you make that paella recipe that you've been making me recently? The likelihood that I'm going to get the paella recipe I want is probably a lot higher than if I just have it, go off the cuff every single time. It will know the flavoring, the ratio of ingredients I like, the various steps that it takes, how to put the mussels in, I don't know, just tons of stuff. Whereas, every time it invents this new dish, this new paella 3.0, obviously it's just like going off of its own biases and randomness at that particular moment. So in addition to directives and executions, we also have two essential configuration files. And it's actually in practice a little more than two, but I just call it two because it's a system prompt and then it's an env. Agents.md contain the instructions injected at the start of every conversation with the orchestrator. Now, these are named according to your IDE environment. So this could be Claude.md, Gemini.md, or it could be whatever the heck it asks for, Cursor.md, whatnot. I would just always have like all of these simultaneously. The reason why is because if you just have all of them simultaneously, you can just like move into any new IDE or any new agent or any new model, and it'll just like immediately understand what you're saying. So in this way, you could theoretically have like, rate limits for your Gemini model, and then rate limits for your Claude model, and then rate limits for your OpenAI model. And you just open all three of them in tabs and just have them all work on things to minimize the probability of you running over anything. Most models at this point are pretty similar. We've kind of converged to really, really similar accuracy ratings and scores and stuff. So aside from preference and stuff, this is how you keep those costs low. In addition, your env file is where you store all your API keys and then your credentials. What this ends up looking like, for instance, is just using that Claude example earlier. If we want AI to do something, we would actually have Claude, or rather Anthropic _API _key. And then you just have like the key itself right over here. Then over here, you'd have like open AI _API _key. Then you'd actually store that key over here as well. And you just like dump this. It would be a massive list of just all of like the credentials and keys that you'd ever want. Your execution scripts, instead of having to hard code the key, would just say, hey, go into env and then find it instead. And there's just like very simple programs that do that sort of thing for you. Just so we're all on the same page, what AgentsMD actually does is it acts as your persistent context. You inject this automatically every single time at the beginning of a session, so you just don't ever have to repeat yourself. It also explains the DOE framework structure to the orchestrator. So everything that I've done here, we are basically going to turn into an agents.md file and then just give to the orchestrator so it understands what is going on. We're going to give it to our agent and be like, hey, make sure to do it this way because it's reliable and because execution scripts are pretty deterministic, so on and so forth. So it's really meta, right? Like everything I'm telling you right now, we're just going to tell to the agent. We're just going to do it in a very like context compressed way. This will also define the error handling behavior so the agent does not spiral when something breaks. And then obviously what's really cool is you can actually just make your agents.md better and better and better. Like I find routine edge cases that I didn't handle for with my agentsMD probably like once a week. And then I just like add a line to it. And then the next time, like my model just doesn't make that mistake. I did not always self-anneal, for instance. I just realized that, there's some situations where my model solves the problem itself, and then other situations where it comes to me for help. Why don't I just make it explicit? Hey man, I want you to solve the problem for yourself. That is what resulted in the self-annealing concept. All right, so let's actually go and have AI set up directive orchestration execution for us. I'll show you guys the system prompts, agents.md, .env, and everything. Okay, so let's actually build our very first real agentic workflow together. the first thing you need to do is open up your IDE. In my case, I'll be using Visual Studio Code for this demo, not because I think it's better than anti-gravity or anything like that, but just because I want to show you guys you could use whatever the heck you want. It's all interoperable these days. Anyway, the very first thing we need to do is we need to create a new workspace. So I'm going to head over here to the top left-hand corner, and then I'm going to say Open Folder. From here, I'm going to, at least on a Mac, click the New Folder button. Then I'm going to say YouTube Workspace, Do. Then going to Create. Once I'm in it, I'll click Open. Next up, what we have to do is we have to create our system prompt file. I get a lot more into detail about these later, but for now, what I'll do is I'll open up this file. I'm going to type claude.md. I'm going to paste in one of the examples that you can get in the top link in the description. So that is this, my system prompt. I'm then going to save. The next thing I'm going to do, I'm assuming you've already downloaded Claude Code. If not, you head over here to extensions, type, in this case, Claude Code, but realistically, whatever model you want. Give that button a click install over here. You're going to need to sign in and all that stuff, but assuming you have your own key and assuming you have your own account set up on at least, a $10 or $20 a month plan, you're good. I'm then going to go to the top right-hand corner here, click this little Claude Code button. And now I'm just going to move back a bit and start asking it to help me. Now, what I want to do is I want to build a simple email onboarding flow. Essentially, when somebody joins my organization, as a client, I want to send them a brief email saying, hey, thanks so much for joining. Really looking forward to having you. And, here's a link to a kickoff call that you can schedule. This is a super easy and straightforward thing to do. And you can, of course, set up systems to do this outside of AGENTIC workflows. I'm just showing you this because I think it's probably the most straightforward example to show you how to chain together 3 or 4 things that I can think of. We'll progressively design more and more complex workflows, but for now, what I need to do is I need to talk to this model. I need to have it do things. But if you notice on the left-hand side, I don't actually have the workspace itself set up. I just have this claude.md. So the very first thing I'm going to do is down here, I'm just going to go bypass permissions. Whatever model you're using probably has a bypass permissions mode nowadays. And I'm just going to say, set up my workspace in accordance with claude.md. I could have said whatever. I could have said just set my workspace up or something like that. What it's going to do is it's going to read through claude.md. It's going to understand how this works, and it's going to create a full directory structure based off that now. Okay, it's adding a bunch of information, webhook.mds, talking about the deterministic and execution layers and so on and so forth. Now it's going to go through and verify the final setup, and now it's giving me a brief summary. Okay, great. Now that I have this set up, I want to show you guys how easy it is to actually build this workflow. All I'm going to do is I'm going to give it a very high-level natural language instruction of what I want. Hey, I'd like to build a brief onboarding workflow. Basically, I want to be able to tell you onboard client email at example.com, and then have you send an email to that new client that introduces them to our company, gives them some background, and then invites them to a kickoff call using a calendar link. Then going to press enter. You'll notice that because I'm using my voice, sometimes this text is a little bit misformatted. That's okay. It doesn't need to be perfect. This model is smart enough to understand what's going on. It's going to ask me some questions. What should I use to send emails? SMTP, resend, SendGrid, whatever. What's the company info? What's the URL? Now I need to obviously go and I need to get this information and come back to it. But I should note that I don't even need to know for sure. Hopefully it's clear. I just want to send through my own Gmail account. So I'm just going to say, sorry, I don't know what any of that means. I just want to send a welcome email from my Gmail account. And then I'm going to provide it my own at nixarrive.com. For company info, I'll just give you a brief list of bullet points whenever you send the email. And underneath for the calendar link, just use an example calendar link for now. Cool. I'm giving it some high-level instructions here, and it's going to help and walk both of us through the finishing of this workflow. The first thing it will do is if we open up our directives folder, it'll build this onboard_client.md. If I go up here, you can see there's now an onboard client.md with a bunch of high-level directives with this information. Now, you'll see that it's installing dependencies and so on and so forth. It doesn't fully understand what to do here, but that's okay. What it's doing next is it's walking us through a one-time setup with our Google information. So what I'm going to do is I'm just going to create a new app-specific password. Let's just call it YouTube example. And then I'm going to go over here. I'm going to paste this in. This is now going to take the app password and actually use it to update the .env file. It says the app password saved. We're all set. First, I'm going to ask it, what does the onboarding email look like? This looks pretty reasonable. I'm now going to go through and then edit this template so that we could send what I think is a higher quality template every time. Okay, just spend a few moments here putting together this onboarding email. It says, hi, name. Thanks for choosing to work with us. We're excited to have you on board. Here's what happens next. We hop on a quick kickoff call to align on goals. You meet the team and get synced with your project manager. From there, we'll map out a plan tailored to you. And finally, receive daily updates when the project is complete. Book your kickoff call here. Very straightforward template. I basically just want this to send every single time. So it's just going to go and update the directive and presumably the execution to always reflect this information. And then finally, I'm just going to say onboard Nick at leftclick.ai. And at the end of it, you could see we now have a really well formatted and simple onboarding email. This whole workflow only took me a few seconds to put together. Hopefully you guys see the power for non-technical people, even people that don't understand what app keys are or ENVs or tokens or anything like that, to actually meaningfully integrate with software that we're using. All right, so now that we've seen a little bit about how to set things up, how do you actually go and create like really good directives? Well, you need 4 things. You need a clear objective statement, aka what this directive does. You need some form of input specification. So what data does the agent need to actually get started? You need a step-by-step process, which is a sequence of operations, scripts, and expected outputs in natural language. And then you also need a definition of done. So that's quality criteria. How do you know that the agent has actually succeeded? It needs to be able to grade itself based on its output. For instance, like you'll know you're successful when you have a Google Sheet link URL with at least 100 rows filled in, something like that. You should also, of course, include edge cases. So any known exceptions, if there are quirks with an API, if there are things that come out as error codes that should not come out as error codes, if they have common failure modes, you should actually include all of that in the directive. You should also describe fallback behavior like, hey, if the Apollo scraper we're using fails, try the instantly lead enrichment tool instead. And unlike old automations, you don't have to like build this massive complicated error handling function. Unlike N8N or Make.com or any of these visual coding tools, you don't actually have to go through and like create these error handling flows. You just add one line and you're like, hey, if this happens, then do this. And it's so much simpler. I'd also include some sort of instructions saying what to return if everything fails gracefully. Like a lot of systems do fail really gracefully. They don't even really tell you that they fail. If you expect 100 leads to pop up or 100 YouTube videos to come from your YouTube video scraper or whatever, like one will. It'll technically have done so correctly, but nothing will have errored out. So there's no real built-in way for the model to know unless you make it hyper explicit what happens if things go to plan. That's why you need a definition of done. And then you also need something to say like, hey, if this does fail gracefully, if we're under 100 records, let's say, if that's our minimum, rerun it over and over and over again with wider filters until we get to 100. Don't return this to the user until we have at least whatever he put in. All right, for my next system, I basically want to build a CRM manager for ClickUp. ClickUp is one of many CRM tools that you could use. I really like it because I think it's simple, it's fast, and then it includes a bunch of functionality that weaves together different tools. Like it has built-in messaging, it obviously has documents, I could store my knowledge bases in here, and so on and so forth. But I want you to know the specific tool doesn't really matter at all. You can build this sort of thing out in basically any CRM, so long as it has the ability to connect via API and MCP and that sort of stuff. So basically what I have here is I have a really simple CRM setup called Template Creative Agency. I'm going to pretend I'm a creative agency here. You can see there's a sales pipeline. Inside of the sales pipeline, I have people like Nick Sarayev and Peter Jackson and Peter Smith, Peter Jackson, Sally Lozenge, her last name's Lozenge, Kvoth Arledon, and so on and so forth. Basically stored on this cool little table. And what happens, like any CRM, is people come in through this intake stage, like Bast, Sarayev, and then essentially they are assigned a status. Then as they are updated, I move them to things like meeting booked, and then proposal sent, and close lost or closed won, depending on whether or not they accept the contract. However, I don't really want to interact with it manually anymore. I think it'd be really cool if I could weave this into other workflows, like our onboarding workflow that we made earlier. So how do I do this? I'm just going to ask it to build this for me. I'd like you to be a wrapper around my ClickUp CRM. I want to be able to ask you to do anything inside of ClickUp and then have you automate the process for me. This will also allow us to connect to other workflows that we build around my agency. All of the CRM information is stored inside of the, and let me head back over here and then see what it's called, template creative agency space. Give me 3 ways we could do this. Okay, it's now going to create me everything that I need. The first option is a direct script library. It'll create a set of execution scripts for common ClickUp operations with a master directive that routes requests. That's pretty cool. I would have to invoke it every time. Then there's some sort of conversational idea. Then there's also a webhook bridge. I like the idea of number 1. I want to see if there's a simpler way to do this. Is there any simpler way to do this? Like, is there an MCP or just anything that wouldn't require us building a specific step for every request? It's going to go through and reason. First, it's going to check to see whether or not there is anything out there that would allow us to do this more easily. What it's doing here is it's using a web search subagent, believe it or not. We're going to talk a lot more about subagents later, but subagents have pros and cons. When you use subagents, things typically take a lot longer to finish, but the pro is you isolate the context. And what that means is you just don't need to worry about inserting all this stuff into the main flow. Cool. So this is sort of what I wanted to do initially, kind of cheating here. But I know MCP is just a simple and easy way that I could build something like this. And I'll show you guys more about this later. But as we see here, there's an official, and then there's also a non-official one. What I'm going to do is I'll say, hey, let's do the official. How do I get my API token? Okay, it's giving me some instructions here. So I'm going to head over here. I just need to regenerate this API token. So first I have to put my password in, just bear with me. Next, I'm going to copy this token over, and then I'm just going to head over here and paste it. One thing that you'll find that models do pretty often is, and I don't know if this is because they want to conserve on their own token usage or something, instead of just doing the thing for you, oftentimes they will say, hey, I'm going to find information on how you can do the thing. What is super, super powerful is just to say, okay, great, do it. Looks like we need some more information here. So we need to go to ClickUp in our browser, look at the URL, and then get the team ID. I see it right over there. Let me just paste it in. Okay, and now all I need to do is just restart Claude Code. So let me click this little X, head over here again. I double tap on the page in order to create that new file. Okay, and now I have an MCP. So let me just give that a click. When you type \MCP, you can now see the MCP servers you have. And I'll say, awesome. Can you create a new record for me? So because this is an MCP, it's like a general solution, it's not a specific solution. We need to insert some information about this. So what type of record, where should it go? I'd like you to act essentially as my ClickUp wrapper. Keep in mind that this is a new instance, so I need to provide it some high-level instructions again. So all conversations are going to be related to that space. I'd like you to store this information somewhere. That way, the next time I ask you to do this, you'll do it the first time. Go and learn about the space first. New lead, Peter Rockwell. Okay, and now what it's doing, when I say new lead Peter Rockwell, it is creating a lead in that space. Pretty straightforward. Let's go check and make sure that it's good. And as you can see here, we now have a meeting URL link, as well as a status of meeting booked. Hopefully it's clear. I could talk all day about this and give this all of the information that I want in order to have it, manage my ClickUp CRM for me. So that's one way to do so with an MCP, which is really straightforward and it's super simple. Let me show you another way we can do this, just using like the ClickUp API instead. So I'm just going to exit out of this and then create a new Claude Code instance. I'm going to say, hey, can you uninstall the ClickUp MCP and remove anything in our environment that has to do with ClickUp? I'm doing a demo. Then going to bypass permissions, so I just don't have to worry about it. It's just going to do it all for me. Hey, I'd like you to build a series of ClickUp directives so that I could automate the process of adding records, updating them, and so on and so forth. I basically want you to act as my ClickUp wrapper. I want to do this via API calls. We previously tried MCP, but I'm doing a demo and I just want to do this via API instead. Okay, it's now building this out systematically. So it's going to start by building a base ClickUp API client. It's then going to create CRUD scripts to create, get, update, delete. It's then going to create directives for each operation. And finally, it's going to update my env template. It says with the ClickUp API key placeholder. I did just remove it, so I'm going to have to add that in again, most likely. What's really cool is I know nothing about any of this stuff, and it's just doing it all completely automatically right now. It's writing all the directives, all the executions, literally everything that I need. And so the reason why I'm showing you multiple different ways to do things is because there almost always are multiple different ways to do things. And with AI and agentic workflow builders like this, it's not necessarily that one approach is better than the other. Sometimes I'll try an approach, and for whatever reason, whether the API isn't cooperating or it's just not very logistically reasonable, I will abandon it halfway and then just do another one. There's no reason why I have to commit to something that isn't working, and I can always change things. Nowadays, the barrier isn't really whether or not it's possible. The barrier is basically just, hey, how much time do I want to spend guiding or steering the ship in order to get this thing done for me? Okay, it's now going through, adding all the information that we need. I gave it the API key, as you guys could see above. It's going to essentially loop over as many times as it takes because of what is in the Claude.md. Eventually, it will solve its own problems through a process called self-annealing, and then we'll be able to do things like create tasks, delete them, update them, and so on and so forth. So it's just running through and testing all of the various scripts that it put together. The creating of a task, the deleting, the cleaning up, so on and so forth. So let me give it some more high-level instructions just to tell it I really want it to work within that template creative agency space. I'd like you to do all of your tasks solely in the template creative agency space. Update everything to reflect this. Then update whatever you need to in order to reflect this. Then create a new lead called Nick Sarayev. Cool. Looks like it already knows what it needs to do. So now it's going to create the lead. And you can see it's even given me a link to the lead so that I could pull it up and see it for myself, which is pretty cool. Awesome. Why don't we see if this has access to some other fields? Do you have access to custom fields? Okay, first it's going to see the custom fields in this list. It's then going to see if we could set the appropriate one. Nice, that's pretty cool. So whereas the other one could not set custom fields, this one can set custom fields, which is pretty sweet. As you guys could see, sometimes there's pros or cons to different approaches. This one was really awesome. So to be honest, I now basically have like a whole CRM manager. Great, delete the record. That was just for demo. I'd personally say having some sort of CRM wrapper like this now with the power of current technology is like a non-negotiable. This thing just makes our lives so much easier. And what's really cool is we could weave flows in together. So when somebody becomes a new client, for instance, we could then automatically send that onboarding flow, then maybe even reflect that by adding a comment or something like this. These things will supercharge any CRM very, very quickly. Okay, I want to talk a little bit about Claude skills. This is really similar to Do, like we just chatted about, but it is specific to the Claude family of models. So you can't use the same Claude skills structure that I'm about to show you in like Gemini or OpenAI or GPT 5.2 or whatever. It's very, very specific to Claude. That said, all of these model families now have their own versions of this, so I wanted to cover probably like the most popular one just so we're on the same page. I care a lot about interpretability and modularity, so I want to be able to use the same workflow setup in, Model A versus Model B versus Model C. Claude skills are obviously hyper-specific to Anthropic's model. Now, this was their attempt to standardize agentic workflows into reusable portable packages, and just like Do, it's a folder structure. It contains instructions, scripts, prompts, and resources that Claude will load every time you call something. So it's just a slightly different folder structure that includes a file called a skill.md, and I'm going to run you through that in a moment. The way that skills work in a nutshell is just ignore the left-hand side of this graph because I think this is a little more complicated than we probably need right now. But basically, you have your agent, and your agent organizes things into these skills folders. And so it's a skills folders / whatever the skill that you want it to know is. So in this case, there's a skill called BigQuery. Then you see there's a capital skill.md with a data sources.md, a rules.md. Over here, there's an NDA review, which includes a skill.md. The skill.md is just your directive, right? And you'll notice that because it's in Markdown. Everything else here is entirely up to you. And so it's sort of like a loose framework right now where people are just dumping in whatever the heck they want the agent to have access to. It's also just a form to a way that you can modularize things. And basically what you'll do is you'll just have like a big list, a big directory called skills. Then underneath that, you will have things like, hey, let's do BigQuery. Let's do one called docx. Let's do one called PDF. Let's do one called, I don't know, scrape leads. And each of these are going to be folders themselves. So very similar to Do, it just takes a slightly different approach. Instead of having like the executables and like the scripts and stuff like that stored in other folders, like an execution scripts folder, it just stores it all in the exact same one. The way I treat things is as an instruction manual that Claude reads first. There's one slight difference between the way that the Markdown file is written insofar that it uses what's called YAML front matter. YAML just stands for yet another markup language, by the way, which is really funny. There's like a million different ways to do this. But basically, what this is this is like a short, I don't know, 100 character, 200 character description of what the skill does. So as opposed to with, the Directive orchestration execution framework, I don't usually use YAML. I just like have it whip it up, although YAML I think would be an improvement. Instead of just naming something really descriptively, what this does is actually just provide some context. Hey, this script does X, Y, and Z. Hey, this a skill asks for this thing. And then, what'll happen is upon runtime, Claude will load the skill based on whatever task you're asking it to perform, just based off of the YAML front matter, which just means it saves a lot of tokens. It doesn't have to read the whole thing. So this is just a small block of metadata at the top of the file. There's like a name field, there's a description field, and then there's a purpose field, and I'll show you an actual concrete example in a second, and then it's like kind of separated like this. And then when the agent loads the file to actually like search through your skills, you say, hey, I want you to scrape some leads. It'll actually just load this. So it's way, way shorter. Small metadata allows it to, only load a few hundred characters at a time as opposed to big chunks. It allows it to understand what the skill does without reading the whole thing. Now, there's also a big library of pre-built skills right now for common tasks, mostly relating to documents. And these are just skills that have been like hyper-optimized over the course of tens of thousands of runs. You can think of them as execution scripts and directives that are just really, really, really self-annealed, and they're just really, really powerful. So we can do PDF creation, do Word documents easily, Excel spreadsheets, PowerPoint presentations. The quality is surprisingly good. And because so many people have run these things, because they've optimized the hell out of it, they tend to execute super quickly, and then they also tend to be like pretty reliable. All right, let me show you some Claude skills in action. Let's talk about how to build things in Claude skills format instead of Do format. I want you guys to see it's more or less the same thing. This is just highly Claude specific. So I have a simple task in front of me here. I want to create a new Claude skill called generate-report. And I want this to build a weekly weather report with publicly available information from some API. I just Googled weather API, pasted this in there. I don't even know if it's going to work, but we'll figure it out alongside each other. I also said I want it Canada specific, just because I'm Canadian, i.e. this report should be all about the weather across Canada. Now, the last thing I need some sort of template. So I'm just going to go and I'm going to see if I could download a free report template. Let's see. It's going to open up a bunch of tabs. What do we got here? 2035 annual report. That looks ridiculous. Okay, this one looks pretty cool. Can I just download this whole thing? Okay, anyway, I'm just going to go over to Canva here. And then I'm just going to download this as, what are we going to do? PDF? Let's just do PDF. We'll do all pages. I'll click download. Once I have this, I'm then going to provide this file to Claude Code. I have a template file in. I'll just drag this over to .tmp. And I'll just call it Orange and Black Modern Annual Report that I want you to use. Go. Awesome. So it's then going to pull that file, and then it's going to, because it knows how to generate Claude skills sort of natively, go through the whole process. Okay, it's going through and then creating the skill directory structure. It's then writing the skill MD with instructions. It's doing a fair amount of stuff. So I'm just head over to here to skills, and then I'll see where this would be. Okay, generate report right over here. Okay, and inside there's a skill.md. Then there's also a scripts folder. This is where we're going to insert these scripts. It's now going to go fetch a bunch of weather data. The cool thing about Claude skills is there's this little YAML front matter, it's called, YAML. And then front matter is just everything that's between these three dashes. And here we have the name, a brief description, and then also some allowed tools, which is really cool. So you can get very granular with how you give your agent access to these workflows. And then what's cool is they only actually load this into context before deciding on which skill to use. So in that way you save a fair amount of tokens because it doesn't have to like read every single file, right? Okay, I'm then going to get an API key. Payment. Okay, it looks like Open Weather Map is not free, despite it saying that it is free. I need to sign up and then enter some payment information. So don't use that. But what I've done here is I've just said, hey, it's not free, so find a source that is free. So now it's going to go and it's going to find me something that is, realistically. Looks like it found an alternative source called Open-Medio, so it's just going to rewrite it with that information in mind. Now that it's done a little bit of work, what it's doing is just testing this skill. Okay, looks like it has now generated me a file. Let's just say Open PDF. Cool, and now we have it. So Canada Weekly Weather, 2025, table of contents, national overview, weather highlights, West Coast, prairies, central Canada. So you guys can see, it is very, very easy to create a template using a PDF. Just drag and drop that puppy in, and then boom, you now have native intelligence that is capable of interacting with tools like this to generate, honestly, a very clean and very sexy proposal document. Pretty straightforward, huh? So, I mean, like, this is just one of many asset generation workflows that you could do. Hopefully you guys see, you could now like generate proposals in a Flash. You could generate any PDF in a Flash, customized assets or slide decks or whatever the heck you want. It really only takes a data source, the template itself, and then you waiting around 5 minutes or so as it self-anneals